Hello there, I'm playing with junk again, and this time I have some medical stuff. It's the Siemens Rapidpoint 405, and that's a blood gas analyzer, so it analyzes all the gases and the properties of human blood. And I want to show you what it does and how it does it and how it works and what's inside. Well, I have to say I'm not a medicine professional. I don't know everything about these devices, but with a little bit of electronic knowledge we can find out what's happening. Maybe not. It's interesting anyway. Let's first see what's on the outside. We have a flat screen, which looks like a touch interface. It certainly is. We have a printer that prints out some data. We have an input port here where you attach your syringe or your hoses or your whatever that is, and there is clearly something missing. I assume it's one of the cartridges for with the cleaning solution or whatever. It needs some chemicals to analyze the blood, and it also needs cleaning liquids to flush everything, because you don't want to mix all the samples together. There is a knob missing, but that's only the knob to advance the paper. No big deal here. On the back side there is some sort of lamp. We can pull that out and we see it's a pretty normal lamp, probably with an electrical connection. The only thing is it has it's glued in place. You can only replace the whole unit, which will of course cost you a fortune. That's normal for medical devices. Oops, it's difficult to do that with one hand. I do it later. Then we have power port, power switch, a network port. I would say 10 gigabit, but more on that later. We have a serial port, and we have a barcode reader gun, maybe to read in some patient forms, and we have a 3.5-inch floppy drive. And that tells us a little bit about how old this device is. Well then, let's turn it on. I had to dim the room lights a little bit because this screen is not very bright, so it's a little bit difficult. So we have a Pentium with 166 megahertz and MMX technology, so that tells you how old it is. I have not seen how much RAM it has. I think not too much, maybe a megabyte or two. Oh, 128 megabyte. That's already quite a lot for the time. Okay, it seems the touch screen is already working, but it takes a while to boot. Oh, that's the progress bar. Yes, it does something. Don't know what it does, but it does. Copyright 2008. It seems there is some new software on it, because I think the Pentium MMX is a little bit older than that. Something is moving inside. You can hear some motors. The printer started printing another logo. Okay, so printer self-test, check. Software version 3.9. Oh, it has to recalibrate the touch screen. It's in German only. There is no language selection. I think there is not enough room on the hard drive for multiple languages. Okay, it says we have to replace some of the cassettes, whatever cassettes they mean. Okay, waste cassette. Yes, see, it can't open the door. Maybe the door is missing. Don't know. Come on. Okay, it complains about missing parts. But what I wanted to show you is the manual, which is built in. So it's the user manual, and what we have here, let me see if I can move that. Okay, there are videos, for example a video how to change the cassette for the waste and wash and waste cassette.
Sie sich zuerst folgendes Video an. Tauschen Sie anschließend die Kassette aus. Öffnen Sie die Gehäuseabdeckung. Entnehmen Sie die Spülabfallkassette. Nehmen Sie eine neue Spülabfallkassette zur Hand. Setzen Sie die Kassette in das System ein. Drücken Sie anschließend auf die Kassette, bis sie einrastet.
Yeah, I think you know what's going on. So I see we can open that door here. Yes. That's the door you saw in the video. And that's the waste and wash cartridge. Yeah, there's a couple of connections here on the back side. No liquids inside, probably. We will see that later. Okay, I think it's time to take it apart. Let's just go out of that menu, power off, yes, and it shuts down. Please wait, writing unsafe disk. So turn off power switch. Wonderful. I just hope there is still enough interesting stuff inside the machine and not only in these cartridges. So we should be able to remove that cartridge. Oh yes, it falls out by itself. That's the input for the samples. Some rubber bands. Oh okay. That's with these rollers here, that's rubber tubes and rollers. That gives us a peristaltic pump. So the rollers roll over these tubes, squeeze it and move the liquid inside forward or backward. Don't know which way they pump, but they do so. We have a lot of electric contacts. Yes, that's a little PCB here. Some gold contacts. There is some mechanical thing. Looks like a temperature sensor here. Maybe, maybe not. It's the COOX cartridge. Oh, I forgot to show you what all we can measure. I think I turn it on again to show you that. While the machine is starting, there are some interesting details on this cartridge here. So first of all, the machine tells us we have to use the green cartridge and not the blue one, because the green cartridge tells us it's for a 405 system. And there is a little list what this cartridge actually contains. It contains 75 milliliter of zero calibration liquid and 230 milliliter of what I can see it on the display, of 200 calibration liquid, 60 milliliter of RCX with gases, salts, buffers and glucose and everything. So that's basically some reference liquids to calibrate the whole system. Yes, and the same in French and German and all that stuff. Okay, that's some stored data. What this device here measures is the pH level, the acid or oops, what was that? Sorry, the acid level of the blood. Then we have CO2 in pressure. We have O2 pressure. We have O2 in percent. So that's the saturation of oxygen in the blood. This should be close to 100%, so that's maybe okay. Natrium, kalium, calcium, chloride, glucose, that's the amount of sugar you have in your blood. That's also, and it also shows you that it went up since the last measurement, so this is stored per patient. You can make a patient file and save all the data, all the values. I don't know what that is. Maybe someone can explain all this abbreviation. O2, yes. CO, metabolic, I don't know. Yeah, maybe if there is a doctor watching this, please write in the comments what all this stuff here means. Don't go too much into detail, but yeah, so all these things can be measured with this system, and that means for all these things there must be some sort of sensor, some sort of thing that converts it into a usable electrical value that can be digitized, stored, displayed, whatever. Okay, now it's time to look inside. Well, I assume that most of the magic happens inside these cartridges that I just took out. But let's see what is hidden behind the rear panel. Oh, for example, an air filter, which is still pretty clean. Maybe this was used in a clean environment, I hope so, or it was changed recently. Alright, the plastic cover is gone. It was 2 screws here, 2 screws here, and a lot of plastic fragments fell out, so I think this device had a rough time before it landed in the dumpster, or maybe it was a rough time when it landed in the dumpster. Okay, we see some boards, we see some stuff. I finally opened the device and you can see the logic board and the power supply, which is quite a bit dusty, so it seems the air filter wasn't that effective. You can only see it here on the fan, so they probably cleaned or replaced it shortly before. Then we have the Ethernet cable that goes from the connector on the back side just to that connector, and then up here and to the main board. Where was it? Here. So that's just an extension cord for the Ethernet. Then we have a hard drive, parallel ATA, or yes, something like that. Oops, I bent some pins. How big is it? What's the capacity? C8. Well, capacity is right under that sticker. Ultra ATA. Okay. Well, I think it's probably 200 or maybe 500 megabyte to be optimistic. Then we have 2 black hoses that go into some sort of sensors here. This one is only connected with one small cable, or only one wire, or is it optical? No, there is nothing else connected. That's funny, only one wire. Maybe ground comes from the chassis. But what are they doing with that? I don't know. There is a lamp. You can see a lamp inside. I still don't get it how this is connected. It's from Bayer Corporation, great German chemical company. Then we have that thing here. Oh, maybe there is a connector on the other side. No, is not. That's funny. A huge board with chips and power regulator and stuff, but only connected with one wire. That's wired. That's weird. Yeah, it's only one single wire. How's that working? A one wire interface with no ground? Well, at least that module here has a connector that goes to the outside. Yes, it's that one. Ah, okay. That's where the lamp goes. That lamp here goes into this sensor, and this sensor here has its own lamp, which is driven by one wire. I'm still puzzled by that. Then we have some mixing of hoses, and in fact that's a funny detail. This cable clamp here snaps close, holds cables or hoses, and opens again like that. I have never seen that mechanism before. That is quite interesting. A snap-on, snap-off cable clamp. Funny. We have something from Join Ibong Inc. from Edison, New York, USA. What could that be? I don't know. Something in an aluminium case. That's always interesting. Then we have one big card here which contains RAM and some interfaces. So that's Intel. Is that the CPU? No, that's a little bit too small. That's the CPU. Okay, that's probably the CPU. So that's a PCI card PC. So that's a PC on a PCI card. And you only need a PCI card bus adapter to add more PCI cards. Also an interesting detail, it says Chiron Diagnostics, and that's quite common with devices of that type. The manufacturer on the outside is most likely not the manufacturer, it's just the brand that sells it, but the electronics and everything, all the physics package here comes from other companies. Most of them not known to the public, but probably quite famous in their own business. I just discovered another interesting detail in the hoses that go to these sensor devices here. There are glass fibers inside. So now it's a little bit clear how that could work. So the single wire provides power, just power, and the result of this optical analysis comes through these fibers here and goes then to a sensor that is somewhere else. So that's probably the way how that works. I just take out this took this aluminium box out here, and there is one hose going in from the samples, and there's one cable going out probably to the computer board. Let's see what's inside. By the way, there is another date code, and that makes a little bit more sense than 2008. It's 02, 2002, 30th day of December. So they obviously had no Christmas holidays and no New Year's holidays. They worked through at least until the 30th. And what we got is PCB with no components on this side. But hopefully there is a little bit more on the other side. Yes, there is some Altera, probably, most likely. It's a polychromator board. So I made that Altera chip visible. It has a funny finish, it's glossy, that's not very usual. Normally chips look matte black like this. That's an analog digital converter. You can clearly see it's from linear devices. AD677, very easy to see what it is. As I said, it's a polychromator board, and probably that's the polychromator, and as most of these gas analyzers, they use optical methods to find out how much of which gas is inside, because they use the property of these gases to absorb certain wavelengths of light. For example, CO2 absorbs infrared light or reflects it, and if you shine an infrared lamp through a CO2 cavity, there is less infrared coming out than going in. So that's some reflective mirror thing with some foam on it. Yeah. Oh, that's the input. And we also have glass fibers here. So probably it's also a filter here. So there is some sort of light source that shines light through the gas, and some of the light is going through this glass fiber to other parts of the electronic compartment. We have to see where these things go. And in the same way, the gas that is analyzed goes into the tube, into the sensor array thing. That looks like the backside of a CCD detector. Let's see if that is true. First remove that cable, then remove the entire thing from that plate. Okay, it seems that was also the cover. We have some sort of mirrors here, if that focuses. We have another mirror here with an arrow. And there is some sort of sensor, maybe a scanner, a one-line CCD sensor. Let's see if we can open that. Maybe not. Okay, it seems I probably have it the wrong side. I explained it wrong. So that's Biodiagnostics Corporation. It's a diode array board. And that's the diode array. Maybe there are diodes for individual wavelengths to see which wavelength will be absorbed or reflected more than the other. What I'm missing is some sort of light source, so that's the diode, that is the sensor. Here are mirrors of all kind, and I think the truth is the other way. They use this fiber inside this tube here to get light into this device, and that is the light emitter, or in fact the end of the fiber here. So that means gas, and the necessary light for the analyzer comes through this hose connection here. And I think the only way to find it out is to see where this hose goes and what's on the other side. I remove the main board, and that's one of these hoses. Seems this screw wasn't tight, so I loosened it before, but I wanted to show you that. Okay, it doesn't matter. So there is the end of the fiber. You can see that here. It's probably, it's just a very simple fiber, and it's not even polished or something. it's also a little bit a thicker fiber, so there are multiple fibers together. It's like a, yeah, it's just a light guide from one place to another, and that goes into this aluminium box here. Let's remove that. And there is some sort of sensor. Looks very nice. Maybe an expensive device. Looks like a 1 pixel photodiode of some sort. Not socketed, okay. The battery has probably seen better days. Looks a little bit blown up. And that's the whole computer, PC board. As I said, processor, Intel chipset, serial port, ISA bus. Then we have interfaces for, well, I think these two are probably for hard drives. That's probably for a floppy drive or something else. I think that's a standard off-the-shelf PC, slot PC board. That's the CMOS battery here, of course. Yeah, that's a PS2 connector for a keyboard, Ethernet. So it's all in. It's a complete PC on one board. Yeah, maybe a power connector or a power output to supply power to other things. Maybe another serial port. I don't know. Is there a manufacturer? I can't see one. There is a part number, but I don't think that tells you much. There is something like another part number. That's probably only the serial number on top there. Ah, here is it. Hard drive interface, flat panel interface, of course. So that means the graphics card is also somewhere here, but it doesn't need much, only to drive this flat panel here. So we could connect that again and see if we get a picture on that screen. Yeah, no manufacturer visible. Maybe underneath the RAM. No, there's just a little bit more of RAM. Maybe the video RAM. No, I don't see anything. Okay, nice one. I think I will keep that a little bit to find out what it actually is and what it could do. To connect the flat panel, that's a bit difficult because that flat panel connector goes here, and from here over this special one big cable here to the rest of the machine. And then we have some CPU chip, MC68332, maybe it's an IO, a UART chip, a multi-interface something. Yeah, there's not so much. Some drivers here for some powered stuff. Oh yes, there are of course a lot of stepper motors, so I think that's probably the stepper motor drivers with heat sinks that are only attached to the board, so they give their heat to the board, and the board dissipates it a little bit through these heat sinks. I don't know how effective that is. Maybe something on the back side would have more effect, but that's low power stuff anyway. Let's have a look at all the mechanical stuff here. There is a stepper motor that drives this clamp here up and down, and that's only to lock. That's the lock mechanism here to lock this cartridge in place. So that's one motor doing that. Then is certainly another motor, or maybe two, for these pumps here, these peristaltic pumps. There is another thing down here that locks the front cover. So I assume that moves somehow, somewhere. Maybe yes, maybe no. Let's break it. Yeah, there's a micro switch. Ah, maybe that's only a switch to detect if the cover is open or not. And I think my assumption was right. There's the floppy drive, there's the cable that comes from the floppy drive, and that went directly to the PC board. So one of the big connectors there is a floppy connector. And down here you see one of the motors of this peristaltic pump, and there is another one on the other side, just as I assumed. Yeah, that's about the mechanical thing. That's not so exciting. There's also a carrying handle here and the mechanics for adjusting the screen. So I think the real magic happens in this cartridge here. On the cartridge there's another mechanical device that pulls this adapter here back. This adapter where you can put a syringe or hoses or whatever filled with patient's blood. It pulls that back, and then a pin, a needle that is stationary, pierces into this sample container and draws some sample out of it. So that's like a little vampire sucking blood from that sample. That's how that works. I assume there is a little hole. No, it's not pointed, it's round. You can't hurt yourself. So the question is, how do we open that? Because it's not meant to open. You replace it as a whole thing. Okay, let's see if that works. Well, there is a first screw under the label. I hope there are more screws hidden somewhere. Yes, for example here. I mean, somehow they have to assemble that, and that means there is also a way to disassemble. There is another one. Well, that's already it. Okay, icy liquids. Interesting. I hope this is clean. I think there is no stuff inside that could be dangerous. I hope so. So there is some liquid here. Well, what was it? When it is new, it has 230 milliliter of 200 calibration, 60 milliliter of, that could be that one, 60 milliliter, 200 milliliters, probably the big bag here. Yes, that feels like it has something inside. And there are 75 milliliters of zero calibration. Oh yes, it's, you should read 200 calibration. That's that stuff. That's 230 milliliters. Then we have RCX. Is that stated? Yes, 60 milliliter of that. And we have the zero calibration liquid. How much is that? 75 milliliter. Yes, it's also a small pouch. Okay. Question. So that's the mechanism. We can see it a little bit better. Goes in, goes here, goes to this, whatever that is. I thought that that's only the connector, but I'm probably wrong. Okay, when I took it out, I felt that this part here is getting warm, so they're probably heating up the entire plate here. So that's probably also some sort of, no, I don't think so. But it's probably also some sort of heater. So this, I mean, all the blood and all these chemicals here probably need to have a human body temperature, maybe. So that's another small hose. Maybe it's the same hose going here through that. Yep, that is some sort of connector. That is also a connector. And there is a ground plug, or maybe that could be a heater connector. Let's disconnect the connector. Okay, so we have, yeah, that's probably a heater. That's most likely either a temperature or a humidity sensor. And there is a locking mechanism for the module itself, probably. Okay, super tiny hoses. Okay, there are a lot of more hoses like here. So maybe that's for cleaning the entire thing. Maybe, yes, it goes in, takes a probe and wipes it clean in this moment and making it ready for the next sample. Okay. I hope I don't spill that stuff everywhere. And I assume this waste cartridge here, wash and waste cartridge, is not very interesting, because I think that's only a container to collect all the, well, the waste of this module here. So I think that makes not much sense to open that. Maybe there is even some nasty stuff inside. I'm just wondering how that works here, that mechanism. So because there is no screw, maybe I can push that. No, it's not that type of contraption. Yes, I fear that sooner or later I will spill some stuff over my bench here. Oops. Yes, that's what I planned to do. So that's one of these hoses comes from that bag and goes to this cleaning or sample mechanism. push on that. Yes, there is some liquid coming out. Tiny little drop. Yes, whatever it is, I hope it's not too toxic. Don't know. I put it in a way it can't do anything, and I will wipe that off. Yeah, I think it's mostly water, but who knows what's inside. One thing is clear, there are no dangerous germs inside, no coronavirus, hopefully, at least not from the patients, when then from the manufacturer, but I don't think so. I hope they are working clean. Okay, how did I do that? Oops, like that. So we have some red liquid here. It doesn't look like blood, it looks like something else. It's quite... It looks like ink from an inkjet printer. Yeah, some sort of dye. Maybe it's good not to get that on your clothes, because it looks like it could stain your stuff. And then there is another pouch. Okay. And there is also a clear liquid. You can see it here. Not too exciting. And that looks as if some of this purple liquid gets into this white liquid. Okay, as I said before, I have no idea how this works, and I don't want to spend a lot of time to find it out, but yeah, I think that looks pretty interesting. Well, I think I know now what that could be, because there is an electrical contact with a cable. I saw that before, and it could be the pH measurement tube to measure the acidity of, well, whatever the sample is. And that works. I don't know how it works, I just know there is the liquid here is what you actually measure, and the liquid, the red one here, or maybe that's only an electrode, I think it forms some sort of battery that generates a voltage, but I don't get where the other pole is. It's only one electrical connection. Maybe the liquid itself is conducting. So that could be the measurement tube for the pH value. Probably. Maybe I'm completely wrong, but it looks a little bit like that, because I had one at home that was made of glass, and it also had a second container with some liquid inside. Well, I don't know if that red stuff is actually liquid or not, but yeah, that's probably that, because there was no other device that could measure the pH value. I wonder how they measure the glucose, the sugar value. Maybe it does that. I don't know. Okay, so I think that was it from that device. A little a chemical laboratory in a portable electronic case format with some replaceable modules full of fascinating liquids, which I have on my finger now. I have to wash my hands anyway. And another advice, if you get your hands on a medical device like this, or maybe something with a respiratory pump, a respirator, keep these hoses to do them to the side, check them out what exactly they are. For example, some are labeled like this one. Come on, Saint-Gobain, big French company doing all sorts of physical and medical stuff. Because some of these hoses they use in this equipment are very rare, very special, very expensive, because I once found Nafion tubes, Nafion, N-A-F-I-O-N, and I found out that 1 meter of those tubes, with about a size like that, 1 meter of them costs $100. That means it's $1 per centimeter. It's not that tube here, but something similar. And they have very interesting properties. You can blow gases through these tubes, and moisture can pass through the plastic material. It can pass from outside into the tube if the gas inside is dry and the outside is more humid, or it can pass from inside to out when the inside gas is moist and the outside is dry. And they can also be used for fuel cells. So watch out for the tubes, and also tubes in this size. I don't know where you really can use them, but if you really need them, they are hard to get, and there's not much to put to the side. There's always a little bit space in a drawer. Yeah, I think that's it. Thanks for watching.